In this problem, we want to synthesize this compound, so we are going to use retrosynthetic analysis, disconnection approach, to make this from small molecules. So the first step that I'm going to do is now disconnect here at the double bond and make this come from a Wittig reaction, or and here let's just visualize the two fragments. So that could come from having, you can use formaldehyde as the fragment on the other end, putting the O in here. Remember that when you use Wittig, I'm using the disconnection to make this molecule with Wittig. There's always two ways. You can start here putting the oxygen on this end, or you can do the other path, putting the oxygen on the other end. Now, here, I would need to do this. And that with triphenylphosphine, pH3, and butyl lithium. So make that. So that would be possible, but I find that I'm gonna do another way yet, which is the other Wittig disconnection. The other Wittig disconnection will involve the following. In this one, we're gonna see which one is better. So here I'm putting the O on this end, which means the next fragment is simply going to be metal bromide, and that reacting with triphenylphosphine and all of that to make my elide, right? And that we do in butyl lithium. Your elide is going to be this. And this we're inserting here to get our alkene. This pathway give me the possibility to add this in, say, Michael fashion. If I have this molecule in, let's disconnect now here. If I disconnect that there, I can think of in, this would be dimethylamine doing a Michael attack here. So the at the beta position, we will do that. And that would lead to the following alkoxide. This will be here. And I will have the amino group what I want it to be. And this, you do a proton transfer step. Say that you have water here. This is only one bond. I need to make my line better. Okay, and so now we will do this. That's the enol, and we know that this enol is in equilibrium with the keto form, which is what we have. So I'm going to draw a couple lines saying that this goes here. The equilibrium favors the keto form. So that step is a tautomerization. So like this, but with better, because here then it will be harder to put the disconnect that they are here. As I can figure out how to install the amino group using that addition. This is a 1,4 addition, so in a Michael fashion, I can get that. And so my molecules will be small. This is simply, here I can still make this even smaller. This fragment is dimethylamine, but this has 3 carbons. If you want, you can make it smaller by doing another Wittig disconnection. But essentially, this already has 3 carbon atoms. That could also come from this right here. We can think of these coming from an alcohol, for example. So here and do the dehydration. In the dehydration will give me this conjugated system, so it will be favor if I do that, if I have the OH in that position. But here we're good in the sense that we already have made the synthesis with a fragment containing 3 carbons, 1, 2, and 3, and a secondary amine. So that path should work to make this.